Okay, I'm going to work on graphing the rational function. Okay, and also working on getting the domain and range of that function. Okay. Okay, so we had that function f of x equals x squared minus 4, x squared minus 9. Okay, so remember we have to factor. So I'm going to factor, just rewrite it. So this is a difference of squares. So x squared minus 4 would be x plus 2, x minus 2. On the bottom, that would be x plus 3, x minus 3. Okay. So we don't have anything that's common on the top and bottom. So that means you do not have any wholes. Okay. So we just look at the bottom to get our vertical asymptotes. So let's get our vertical asymptotes first. Okay. So our vertical asymptotes is going to be solve for x would make it equal to 0. So x cannot equal -3 and x cannot equal +3. So those are our restrictions. So you cannot have at -3 and also at +3. Okay, so we have two vertical asymptotes. So your vertical asymptote will be x equals -3 and x equals +3. Okay. Okay, so now to get the horizontal asymptote, remember you look at the leading coefficients. Okay, now to see that the degrees are the same, so all you do is divide the leading coefficient. So remember, there's no number in front, so that's a 1, that's a 1. So when I divide 1 over 1, gives me 1. So that means your horizontal asymptote will be at 1. All right, so your horizontal asymptote will be y equals 1. Okay, because it's going to be a horizontal. So remember, equation for any horizontal line will be y equals, any vertical line will be x equals. Okay, so that's why I have x equals for your vertical asymptotes, y equals for my horizontal asymptote. Okay, so then now once you have that, then you can sketch your graph. Okay, you can go to Desmos, and then you can put that in so you can get an idea of how to graph that. So now if you're sketching a graph, I would start out with the asymptotes first. Okay, so just do it by hand, so at least show you so you have an idea what I'm talking about. Okay, so on my graph, okay, so we said we have a vertical asymptote at -3 and at +3. So I have to do them as dotted lines. And again, it helps you to plot out your graph. And one at +3. So I'll make that a dotted line. And then I have a horizontal asymptote at 1. Y equals 1. So it'll be horizontal straight across at 1. So again, I'm showing you how to do it all by hand. Okay? So now everybody can see that. So now once you put it into Desmos, you see instead of the f of x, just use y. Makes things a lot easier. So you can see that your graph right here in the red, you have 3 lines, right? Now, when you graph it on Desmos, you don't have the line showing your asymptotes. Okay, so that's why if you're doing it by hand, best to do it with dotted lines so you have a guide to show you on there. All right, so you can see that the graph gets close, but it will not cross -3, will not cross +3, and also here at 1. So it get close to 1, but it will not cross. Just sketch right here. So remember on this, on the left side, again, the graph gets close, and it goes up, right? Again, it goes on forever. On here, the graph comes up, flattens out, comes down. Remember, you do not cross those lines at all. And then on the right side, here, just cross. And then here. Okay, so right there, that is your graph on that of that function. Okay, of x squared minus 4 over x squared minus 9. Okay, so now once you have your graph, I think it makes it pretty easy to get your domain and range. Remember we did before, your domain and range from left to right. Okay, so remember this arrow means it goes on forever. So my domain starts out from negative infinity, gets to negative 3. Okay, now since it does not cross there, that'll be parentheses. Then there's another part, okay? And the next part goes from negative 3 to positive 3. So since my next part, I'll put the union in there. It goes from negative 3 to positive 3. And then we have our third part here, okay? We'll go from positive 3 all the way to infinity. So union 3 to positive 3. So we have 3 parts. So that's my domain. Okay, doing the same thing with the range, but you go from bottom to top. So in the range, okay, see this graph goes all the way down. So it goes from negative infinity to this boundary, which is at 1. So it'll be negative infinity to 1. And then it starts again from the boundary on up. It starts again from 1 to infinity. So it says 2 parts. You have a union, 1 to infinity. Okay, so there you go. That's our domain and the range for that function. Okay, so now I want you to try one on your own. Okay, so on here, I want you to find all asymptotes. Okay, also find any intercepts that you have that they have on the graph. Okay, sketch the graph and also find the domain and range. So right now, pause your screen. Okay, see, can you do it? And then we'll see how well you are. Because again, there are some of these questions that will be on the test this week. Okay, so let's see if you did this right. Again, you want to factor. All right, so remember we're going to factor top and bottom. So remember when you factor, we have a leading coefficient of 2 multiplied by here, we get 6, right? Okay, so again, plus and plus will be plus and plus in your parentheses. Factors of 6 are 1 times 6, 2 times 3. Remember to add and get the middle term is 1 and 6. So it'll be x plus 1, x plus 6. But we have to put the leading coefficient underneath both of those. Okay. So put the leading coefficient, put the 2 under here. Okay. This cannot reduce, so the 2 goes in front. So I'm just rewriting right here. So that becomes 2x plus 1. This can be divided. 6 divided by 2 will give me 3. So that'll be x plus 3. Okay. Again, we've done the factoring before. Okay. So that's the top that's factored. I'm just rewriting this in just factored. Okay. Now we're going to factor the bottom. So we got minus and minus. Will be plus and minus. Factors of 12. 1 times 12. 2 times 6. 3 times 4. Remember, plus and minus, you subtract. The middle term will be 1. Negative 1, though. So to get negative 1, which one subtract to get negative 1 is 3 and 4. So it'll be 3 minus 4. So that'll be x plus 3, x minus 4. Okay? So let me just rewrite the whole thing because in case y'all getting confused. All right? So just in factor form. So remember, top was factored to be 2x plus 1, x plus 3. On the bottom, we have x plus 3, x minus 4. Okay? So now, once it's factored, we can see, yes, we have something in common right here. The x plus 3, those cancel out. All right, so the solution would mean that we have a hole in that spot. So we have a hole at x equals negative 3. Remember, it's the solution. Okay, what plus 3 gives us 0? Negative 3. So we got a hole at negative 3. We have a vertical asymptote for the solution here at the bottom. What minus 4 gives you 0 is 4. So we have x equals 4 will be my vertical asymptote. Okay. Now my horizontal asymptote, okay, comes from the original problem. Remember, so the degree is the same. We just divide our leading coefficient. So 2 divided by 1 gives me 2. So horizontal asymptote, remember, horizontal line be y equals. So be y equals 2. Okay. So we have that information so far. So we can start our sketching on the graph. Okay. So you can get an idea what it looks like before you even put it on Desmos. Okay. Okay, so now we have a vertical asymptote at 4. Okay, horizontal asymptote at 2. Okay, and you know you have a hole. Okay, now the way to find out the coordinates of that hole. Okay, let me just write that over here. Okay, so now we have 2x plus 1. That's after we cancel this out. Okay, 2x plus 1. On the bottom we have x minus 4. We said our hole was at -3. So if I put -3 in for x, okay, that'd be negative 2 times -3 is -6 plus 1 gives you -5. On the bottom, when I put in -3 minus 4 gives me -7. So that gives me 5/7. Okay, 5/7. Because negative over negative is positive. And if I divide that out, that'll give me 0.71. Okay, 0.71. So that tells me that my coordinates of my hole will be at -3.71. Okay, that's the coordinates of the hole. So you know at -3.71, somewhere real close. So you got a hole somewhere around here. Okay. Okay, so now once you have put it into Desmos, you can see in your graph, okay, you have your two parts. Okay, you can also see that you have your vertical asymptote at 4, okay, and your horizontal asymptote will be at 2, okay. And if you don't believe me, you can check on here as you go along. Trying to get as close as possible to 3. You see you have that hole, right? Okay, it's undefined. Okay, you can see right there, it's approximately around 0.71. Okay, so you can see that. Okay, all right. Okay, so there is your graph. So that help you to guide and help you to graph it. Okay, when you do it on your paper. Now we sketch our graph. See that our graph is going to come down. Here it goes through that hole. Okay, again, just the best that you can. Okay, just gives us an idea. Okay, so right there, that is our graph. Now to get our domain and range, this is where it's so important. Remember, these go on forever. Okay, so my domain, again, it's going to go from -infinity, but then it's going to stop here, okay, because we do not have a value here. So your domain is going to go from -infinity to where the hole is, which is at -3. So domain is going to go from -infinity to -3, then starts again from -3 to this vertical asymptote of 4. And then from this part here, from 4 to infinity. Okay. So now let's do the same thing for our range. Again, think of it just like your measuring tape. Okay. Are you measuring just how far it goes? So my range from bottom to top. So I'm gonna go from negative infinity to this point. So how high is this point here when we get to the hole from that y coordinate? Be 0.71. Okay. So your range will be from negative infinity to 0.71. And then from 0.71 up to this horizontal asymptote of 2. And then from the third part, from 2 to infinity. Remember, we got unions in between. Okay. So right there, now you have our domain and range, have our asymptotes, also have a hole. Okay, and you already know how to find the x and y intercepts. Okay. Again, you can use Desmos for the test. Again, the more practice you are, the better you're going to be. And I'm telling you, there are quite a few questions on this, on the test. Remember, be ready for the test. If you need more help, sign up for office hours. I can go one-on-one with you. Just sitting there not attempting is not going to help you learn. Again, you still expected to learn and know everything that you're supposed to. Okay? And know that I'm not going to let anyone go to the next grade without knowing what they're supposed to do. All right, so again, hopefully y'all watching the video, and again, do what you have to do. All right, okay. Everyone is in there, so you're not alone. All right, but again, you have support. All right, so again, let's do it. Let's do our best. Wish good luck. Again, reach out. Let me know if you need help, and also let's finish all those assignments on time. Okay. In order to be the best, you got to do your best.